Hi everyone. I'm going to be doing this talk in English. I hope that's okay. So the title of the talk is Your Data is in Kafka, Now What? And the answer is a data lake. So let's get started. I'm Yoni. I'm the CTO and co-founder of Upsolver. Upsolver is a big data platform that basically is trying to take all the hassle out of the big data project and make it just a short and easy experience. And that's very relevant to what we're going to talk about. My background is in big data and algorithms, and basically I think just big data is really cool. It's like one of the like kind of newest things going forward that really have a lot of traction and stuff going on around them. Yeah, so I'll just get started. So let's talk a bit about Kafka. So I think the show of hands was about 50% here actually use Kafka. Can I see a show of hands again? Yeah, well, almost everyone uses Kafka, so that's cool. And how big is your Kafka? Can I have a show of hands who has a Kafka cluster that does more than 1,000 events per second? More than 100,000 events per second? More than 10,000? I skipped, sorry. Okay, cool, okay. So yeah, Kafka basically, the promise, and they totally deliver on this. I think Kafka is one of the best systems that are available today. The promise of Kafka is that you can throw a huge amount of data into it, and it'll just eat it. There's absolutely no problems, it doesn't have downtime, it just works. And I find that that's generally the case, but you need to kind of understand how to work with Kafka. So Kafka is a log, basically. So you're writing data in, and it's just being flushed to disk. Okay, you're writing lots of events coming from lots of different places, it's flushing it to disk. And then when people read from Kafka, they're as if consuming it from the disk. So you're saying, okay, that's a bit heavy. I'm writing to the disk and then I'm reading. So the way Kafka is architected, because it's writing sequentially onto the disk, really what it's doing when it's reading, as long as you're reading from the tip, as long as your consumers are reading right from the end of the data, it's going to be reading from the file system cache that's in memory. So regarding what you were talking about before, the memory is actually important for your Kafka cluster. Generally, the Kafka process itself is going to use very little memory, few gigs at most. But you really want to have enough memory that all of your operations are working out of RAM and not off the disk directly, because that's really going to impact performance. But writing is super easy. If you're producing data, it's always going to be written to the end of the partitions. So you really have almost no limitation on writing. Also, the producer code is the simplest thing ever. Just producer.send, and it sends the messages. You don't have to worry about it. Kafka is actually exactly once from 0.11. That's pretty amazing, like mind-blowing even. Exactly once is really, really hard to do, and they do it really well. But we're going to talk about that a bit later. And also it gives you strong ordering within a partition, which can be very, very useful, especially for smaller data where you can fit all of it in one partition, but also since you can distribute data between partitions, it gives you kind of a lot of guarantees about what's going on with your data. So Kafka producing is super simple, and you know there are a couple of blog posts that talk about Kafka, and there's one that was 2 million events per second in Kafka with 3 commodity servers. And that came out, I think, like 4 years ago, something like that. So it's probably better now because Kafka actually got like maybe 25% faster. But so this is a guy from LinkedIn, or from Confluent rather, and he's saying I got with three nodes that are just basically like 6 CPUs, 32 gigs of RAM. I got 2 million events per second, 250 megabytes per second write and read. And then on the other side, there's another blog post, also written by someone from LinkedIn, saying, well, one of our clusters, which is super cool, does 800,000 events per second on 60 nodes. So I'm like, wait a minute, that's 20 times worse than the other one, or 40 times worse than the other one. So what's going on? And these are like the same people. LinkedIn are the ones who made Kafka, so you'd think they know what they're doing, right? So what's going on here? Why do we have this discrepancy? On the one hand, I can send 2 million events per second on 3 nodes. On the other hand, I can do half of that with 60 nodes, which is really hard to manage. Like, you don't want to have clusters that big if you don't have to. So the thing is that consuming is really hard from Kafka. It's a lot harder than, well, definitely a lot harder than producing. But you have to know a couple things when you're working with Kafka. First of all, you have your file system cache again. And the file system cache is going to keep the last tip of data. So let's say if I'm writing 100 megabytes per second, so I have 10 seconds of data per gigabyte. If I have 30 gigs free on my server, that means I have 5 minutes that's going to fit in my cache. Anything beyond that, I'm going to disk. Now, if I have a bunch of readers that are reading at different offsets within Kafka, so each one of them, and we also have a bunch of partitions that each one is a separate read, so we have a lot of stuff going on. And as long as I'm at the tip, I'm not going to be paying for it. I'm going to be paying for it very little. But once I get beyond the tip, there's a huge performance decrease, which I think really would probably explain most of the 10x or 15x factor between the two blog posts that they were talking about in LinkedIn. And in addition to that, you have, I mean, Kafka is actually pretty expensive. Okay, so the data is stored in a log, it's compressed, so it's let's say relative to databases, it's pretty cheap. But if we compare it to cloud storage, it's literally 10 to 100 times more expensive. So you're paying for, let's say recommendation is 3 replicas, but let's say even if you do 2, so you're paying for 2 replicas, you're paying for EBS volumes, which I definitely recommend using, by the way, EBS volumes, because you can detach them and attach them to a different instance if something fails. By the way, for the EBS volumes that you're using, my recommendation would be to use, they have 4 storage tiers. So you have, actually the HDD ones are better suited for Kafka because you're just reading the log sequentially. And the best value for dollar you're going to get is with the high throughput HDD. And you should kind of limit your volumes though to 2 terabytes, and I'll explain why in a minute. So that's, yeah, I'll get to that. Talking about Kafka production performance and talked about cost. Oh yeah, so about the cost, in addition to the fact, okay, so the storage is costing us probably about double than S3, possibly more. We have several replicas. Also, we're compressing, but not really that well. I mean, if we were, let's say, storing the data on S3 in files, we could create Parquet files, we could compress them with gzip if we wanted to, because it's relatively offline process, so we can get easily a 5x improvement. And that's just the start. You also have servers, right? If you're keeping tons of data in Kafka, you have to have servers to hold that data, and you want like memory equivalent, and et cetera, et cetera. So really, retaining data, if you're talking about retaining a long history of data, weeks or months of data in Kafka, it gets to be really expensive. And people talk about clusters of Kafka with 40, 60 nodes. That's a lot of money for most organizations, I think. So there's definitely a value of reducing that. Another thing is that you're sending data into your Kafka, and consumers are always reading that data, directly from the Kafka, and it's very hard to know what's going on there. You have metrics on Kafka, so how many events were written, but you don't have much visibility into what's actually going on in the topic. So as long as you're reading from Kafka and each kind of consumer is doing its own thing, you really need to do data quality per consumer, per person who's using a different part of the data or different whatever it is. So that's also something that creates a lot of kind of management overhead that you'd rather not do. So all this to say is that you really want to limit the way that you consume data from Kafka. So basically, we propose a different kind of architecture where you have 2 kinds of consumers basically reading from Kafka. You have the real-time consumers. Okay, these are consumers that really care about what's happening right now. Okay, I want data in like under a second, under 2 seconds latency to respond in real time and update some kind of in-memory state usually. So these consumers, okay, they're reading from Kafka, that's what it's built for. They're all reading from the tip. You're not getting file system cache misses. And everything's good with the world. You can have tons of these consumers and it's fine. But the offline consumers, and this is actually, from my experience, it's like 70 to 90% of all consumers are going to be consumers that don't really care about latency, and often they're even batch jobs. So once an hour, I want to read an hour of data from Kafka. Or I spin up a job that I want to read 3 days of data from Kafka. And that's just one entire flush of my cache. So I really want to avoid doing things like that. And for that, you have the hybrid architecture, where you use Kafka as kind of a landing zone. Data's arriving in Kafka, it's super fast, everything's working great there. And you're just offloading data as it arrives into S3. And here you're getting a lot of additional value, because S3 is super cheap. It has almost unlimited bandwidth. You can really do almost anything with it. Consumers aren't going to bother each other, and the Kafka cluster can be much simpler. So you can go back, basically, with this kind of architecture from the 60 broker cluster down to the 3 broker cluster that's giving you the exact same value. And then I was talking about using the high throughput EBS volumes and limiting to 2 terabytes. So the reason is because of this, in blue you see retention 6 hours to 24 hours. So it's actually 6 hours or 24 hours. And basically the idea is that since I'm using Kafka only for the tip, only for consumers that are either in real time or else to offload data into S3, so that people can consume it kind of in an easier way. So I'm actually limited, like what's limiting my Kafka's ability to deliver performance is my hard drive's throughput. So the high throughput EBS volumes give you 40 megabytes per terabyte. But they also give a burst performance of 250 megabytes per terabyte, and that's limited to 500. So up to 2 terabytes, you're getting a maximal burst performance. So basically, biggest bang for buck. And then if you multiply your throughput, so the 40 megabytes per second that you're getting per terabyte, if you multiply that by the size of the disk, you get 6 hours retention. So basically I'm saying, you're paying for the throughput anyways, you may as well have the 6 hour retention you paid for. So if you really want more retention than that, so 6 hours basically is saying, all my offline processes are going to run off S3. I'm only using Kafka for the tip, but I want 6 hours to make sure that if something crashes, I can recover without losing data. But maybe I'm not that confident in my ability to recover in 6 hours. So then you can go from the high throughput to the low throughput HDDs, and they cost about double per throughput, but you're getting then 24 hours retention instead of 6 hours. And both of them give you the same burst performance. So if you do actually want to read the entire Kafka, for example, if you want to create a new replica or something like that, so it can burst and support that without affecting your production performance. So basically you're writing all your data into S3. Basically, this is a data lake. And then you want to, all your additional, let's say migrating, putting the data into databases, completing Lambda architectures where you have the tip is updated in real time directly from the Kafka, and then you're replacing that with offline data from S3 once it becomes available. All these things come from there. So the advantages, to recap, are first of all, you're saving a lot of money, like really, really a lot of money. Also, as far as performance, you don't have to scale your Kafka cluster with the number of consumers, which is a huge deal, because consumers also, they get added all the time. You don't even know who's consuming your Kafka topics probably. So you really want that. And then also, if you're doing a data quality effort, which I'll show you in a moment, at the end of the talk, how we do that with our system, you only need to really do it once, because all your data is sitting in a managed data lake and all kind of is in the same format and structure. So you don't anymore need to deal with a per consumer data quality. Consumers are reading directly from S3. So giving data quality on S3 is equivalent to giving the data quality to how the consumers see the data. But offloading data from Kafka to a data lake, that's not necessarily the easiest thing to do. So let's talk about a few best practices. How do you want your data lake to look like? So first of all, let's talk about just the file format and compression of your data lake. So first of all, it has to be compressed. pretty much like a 3x factor of improvement on your cost. And really there isn't a best solution there, it's more like which one is best for your needs. So Snappy is super fast. There are a bunch of others that are also very, very fast and don't compress very well, but you're still getting some gains, especially on Parquet, by the way. Parquet with Snappy works very, very well. gzip is probably going to give you about double the performance, but you're going to pay CPU time. So it really depends how you're consuming your data. Our general recommendation would be to use Snappy if you're not sure between the two. And then if you're using Parquet or Avro, so Avro is faster if you're just reading all your data. And this is another point, that using a data lake can be a lot more effective than reading directly from Kafka. So if a consumer wants to read from Kafka, it has to read all the data. There's no way to skip because it's a binary per record format. But if you're taking the data from your Kafka and putting it into a data lake in Parquet format, a consumer that only wants a few columns, so I'm not sure actually, I didn't check if everyone knows what Parquet is. Basically it's a columnar file format, so it's storing a file with each column is separated into contiguous bytes. And then, so you can basically seek in the file and only pick the, let's say, the 3 columns that you want to read and ignore the rest. You don't have to parse it, you don't even need to bring it from S3. So that can give you huge, like 10x, 100x performance benefits depending on what your data looks like. So Parquet gives you that advantage. It is slower to write. It's a bit more cumbersome to work with also. Not everything supports it as well as Avro. But definitely I would say converting usually JSON data, which is what's landing in your Kafka, into Avro or Parquet, which are both supersets of JSON, you're going to get huge performance and storage benefits. Another thing is just to make sure that your data lake is sorted lexicographically. So make sure you have that 0 before the month. That's super important because in S3, when you list folders, it lists them lexicographically. So to get all the files that are relevant to a certain something, you really want that. Also, if you have predictable file names, so if you know that every minute you're going to get a file called output.avro, regardless of if that file is empty or not or whatever it is, so you don't actually even need to list because you know what your files are already. And that can also give you a huge performance boost when you're working on top of the data lake. And then another thing is, how do you actually batch the data? So data's coming into Kafka, you have a bunch of partitions, and now you want to offload that into a smaller number of files. And with files, first of all, you want them to be as big as possible, because there's an overhead for each get. So as big as possible, but on the other hand, you want to make sure that they're small enough to fit in memory uncompressed, because a lot of systems are gonna crash if they don't when they want to read it. So make life easier for them. So basically, you're creating files and you're splitting them every certain amount of time, splitting them to different files according to the size. And you want to make sure, though, at the same time, that you have deterministic file boundaries between each, let's say, chunk of data that you're reading from Kafka. The reason you want to do that is that if your process crashes or something happens, you have split brain and 2 processes are running at the same time, if your file boundaries are deterministic in the Kafka cluster, you're guaranteed to get the same file regardless what happens. So then you're a lot more fault tolerant when you do that. And another thing is just for the sake of the consumers of your data lake, it's really nice to have atomic writes if you can manage it. So these are all just kind of best practices on how your data lake should look like. Yeah. And here are a couple more. So one issue is that within Kafka you have a strong ordering within each partition. But now that you have a batch process that's anyways offloading all this data into S3, you actually have the opportunity to create a strong ordering, or let's say it wouldn't be strong ordering based on sent data, but you can create a strong ordering that all consumers of the data are going to see the data in the same order. And this gives you a lot, let's say, better control of how consumers look at your data and synchronization between them. So you're not going to have two processes that see the data in a different way and then you get different results. You're not sure why. You have a lot more visibility into that. Another thing that you're not getting directly from Kafka, and a bunch of systems give this, but you really want it to be at a very high quality level, is you want to see what's actually in your topic. And when it's on S3, that's a very good opportunity because you can store data for as long as you want. You can also extract tons of metadata and do a lot of processes on it. And we could recommend using a schema on read. So basically you're getting the data and building your metadata on top of that as you're getting new data. So you're not expecting a specific schema, kind of like the way MongoDB works. And when you have that, and it's built on top of the image of the data that everyone's looking at, you can very easily find bugs in your data that would be almost impossible to find otherwise. You can do root cause analysis, so it really opens up a lot of possibilities. And then the last thing is talking about exactly once. So with Kafka 0.11, they came out with exactly once in Kafka, which is amazing, like making sure that every event arrives only once into your stream without needing to do anything on the producer side. So the consumer side, that doesn't work. And this is actually a quote from the blog post that announced exactly once. They asked, is it magical pixie dust that I can sprinkle on my application? And the answer was no, actually. You need a consumer that actually does exactly once itself. It's just the producer. You're just going to make sure that the data isn't going to be in Kafka twice. So you need to pay attention to that. It's not the easiest thing to do. But if you do, you're going to get a lot of value. Because then you can do all sorts of things like making sure that the number of events matches the offsets in the partitions and etc. So this is basically drum roll for our system that basically does a lot of this for you. So our architecture, kind of at a glance, is connecting to streaming systems like Kafka, building your data lake on S3, and at the same time giving you a lot of abilities over that data lake. So building smart ETLs that would spread the data around, give you a lot of visibility into what's going on in your system, giving you indexing abilities over the data that's stored in Kafka, so you can actually do historical lookups on all the data in S3 very, very fast. Thank you, and I'll just show you for a moment how that looks like, and then we'll move on to questions. Yeah, so that's what visibility into data looks like, as far as I'm concerned at least. You want to be able to see over any time frame of data that came into Kafka without needing to do anything, by the way. So this is basically just pointed at a Kafka topic and let it run. You see distribution of all your fields, distribution of values in your field, ability to drill down into specific events wherever they are on the within your data lake. Oh yeah, so you're looking at a data of a Twitter stream, the public data that we're just streaming into our system. Specifically, you can see that you have some hashtags, trending hashtags. One of them is World Cup. This is around, I guess, the time of the World Cup. But basically, the idea is that once you have this, you can easily find, for example, that the hashtag, the density is only 15%, and maybe I expected to have more, or I expected distributions that are different. So this is the kind of monitoring that if you have it globally across all your topics, you're going to find a lot of bugs kind of during development and also in the early stages of production. So I think that's super important. Okay, some questions?
How do you generate these statistics?
So what we do while we ingest the data from Kafka is we take the data, and as we're parsing it, because we're converting it to a data lake format, so Avro or Parquet, and extracting statistics and storing basically index files into S3, which is something, it's a kind of a basic building block within our system. And these index files are very small and can be loaded in memory to give you statistics on any time range you want. And since they're all stored in S3, you have the statistics over any frame of time. Anyone else? Okay, well, thank you.